Today we're going to go over two examples using the quadratic formula. And if you recall, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. As a quick refresher, we use the quadratic formula when we have a quadratic equation or function in standard form, and after identifying a, b, and c, we can insert the values into the quadratic formula. Notice the plus minus symbol in the quadratic formula. This tells us that there are going to be two values we get whenever we use it. One value when we use the plus sign, and we get another value when we use the minus sign. So let's talk about two scenarios where you use the quadratic formula. One scenario is when you have a quadratic equation where you have a quadratic expression set equal to 0. Here, we're going to get two values of x that can satisfy the equation when we use the quadratic formula. Another scenario arises when we have a quadratic function that we want to find the x-intercepts of. And the output of the quadratic formula for a quadratic function is going to be 2 points that represent the x-intercepts, where the x value of these points is just going to be the values we get from the quadratic formula, and the y value is going to be 0. So let's begin with a quadratic equation where we're going to use the quadratic formula to find the values of x that satisfy it. Let's work with the example 2x squared plus 5x minus 3 equals 0. And almost immediately we can identify a as 2, b as 5, and c as negative 3. So let's bring up the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so first we plug in a, b, and c into the quadratic formula. Notice we have two values because one value uses a plus sign and the other one uses a minus sign. Next, we try to simplify the quadratic formula. Negative b is equal to negative 5 here, so I'm going to put negative 5 in the same position as negative b in the quadratic formula. When I calculate b squared minus 4ac, I'm going to get 49 here. And finally, when I multiply 2 by 2, I get 4. Next, the square root of 49 is equal to 7, and so we can simplify that. And finally, we add up the numerators. Negative 5 plus 7 is going to be positive 2, and negative 5 minus 7 is going to be negative 12. And when we divide each of those by 4, we're going to get x equals 1/2 and x equals negative 3. That happens to be our two solutions to the quadratic equations. So let's check that these solutions are valid. First, we bring up the quadratic equation that we're working with, which is 2x squared plus 5x minus 3 equals 0. And then we plug 1/2 and negative 3 in for x. We continue to simplify the left side until we get 0 equals 0. And since that is true, x equals 1/2 and x equals negative 3 must be the solutions to our equation. Now let's move on to the quadratic function. And let's try to find the x-intercepts of the function 1x squared minus 1x minus 20. For this function, our a value is 1, our b value is negative 1, and our c value is negative 20. The only difference for a quadratic function is that our output is going to be a little bit different at the end. So let's begin. Let's bring up the quadratic formula. We plug in a, b, and c. We then insert our value for negative b, which is 1. We calculate what b squared minus 4ac is, and that's 81 here. And finally, we do 2 times a, which is going to be 2. The square root of 81 is 9. 1 plus 9 is 10. 1 minus 9 is negative 8. And if I divide each of those values by 2, we get 5 and negative 4 as our two values from the quadratic formula. This tells us that 5, 0 and negative 4, 0 are my x-intercepts of the function f of x. So now how do I check these answers? In order for a point to be an x-intercept, we take the value that's in the x position, plug it into the function, and we must get 0 back. So in other words, if we take our x values here, 5 and negative 4, and plug them into the functions, we should get 0. This is just a little bit different than what we did to check for our quadratic equation. So we bring up our function, which is 1x squared minus 1x minus 20, and we plug 5 and negative 4 in for x everywhere. And we have f of 5 and f of negative 4 on the left here, and then we just simplify the right side until we eventually get f of 5 equals 0 and f of negative 4 equals 0. Since when we plug them into the function, we get 0 back, that means that 5, 0 and negative 4, 0 must be x-intercepts of our function. And so hopefully you now see where we use the quadratic formula when we're working with a quadratic equation and a quadratic function. This is Joe, and thanks for spending some time with me.